Hello everyone and welcome from the biggest NVIDIA event in San Jose, GTC. Today with me a special guest, Amit Goel, the Head of Robotics from NVIDIA. CTO of ABB Robotics, great meeting you. Niclas?
Good to see you, Lucas.
How do you bridge the sim-to-real divide at global scale and why has it taken until now to crack it?
So there are fundamentally three technologies that have come into bear in the last few months and a year, which has really enabled this. First, we can now bring reality into simulation with technologies like neural reconstruction. The second one is the ability to simulate really complex physics, things like deformable with the Newton physics engine that we are building. And the third is the neural simulators, the simulator that can learn from the real world and models like Cosmos and World Foundation models that allow you to simulate highly complex things in a more efficient way. Okay. Putting these things together, now you can bridge that into real.
That's the key name here. So you know the three reasons. First of all, how does the virtual controller of ABB enable 99% of accuracy?
Yes, so the virtual controller of ABB has been developed over years and years and decades. So what we do in the simulated world, what we do in Robot Studio, is the exact same thing that we do in the real world.
Okay.
By using the same controller in the real world and in the simulated world, make sure that everything fits perfect and then we can reach 99% accuracy.
That's an important one. So NVIDIA doesn't build robots, everyone knows that.
Right.
So what exactly your role in the ecosystem and how does the ABB partnership that you have recently announced mean?
Exactly. So if we don't build robots, the partnership with ABB is super important to us. We build computers. We build computers for training, we build computers for simulation, and we build computers for deployment. And with ABB, which is serving all the industries in manufacturing, in automotive, in healthcare, we are integrating our libraries and our tools into their products. With the ABB Robot Studio, now you can not just simulate the robot, you can simulate the world, you can simulate the sensors, train your AI in a synthetic world, deploy it on an edge platform, on an ABB robot running NVIDIA GPUs. So now all the industries have access to that technology through ABB.
What role does NVIDIA Omniverse play in achieving these from the ABB perspective?
Yes, so the first part was that we can simulate the robot very accurately. Now what we can do with NVIDIA is we can take the product data and also the photometric data and simulate that in a very physical fidelity role, so it can be perfect.
So we talked about data, the last question. So synthetic data generated in your, everyone knows it, Omniverse is now feeding AI training pipelines direction. So how good does simulation need to be before it fully replaces the real world data collection?
That's a fantastic question. Simulation is never going to be the only way of creating data. You have to complement it with real world data. However, fundamentally, you cannot scale real world data. You are limited by the number of hours and number of people. That's where simulation comes in. Now data becomes a compute problem, and we fundamentally believe that if you make compute as the answer to data, you can scale it. We have a lot of compute that's coming online, and we'll be able to create a lot of data. So they play together to actually solve the physical AI problem.
Okay. And the last one, can you just walk us through a real scenario? How does the manufacturer use hyper-reality? That was a big bang.
Yes, you know, that's fantastic, right? So you do what you've done always in Robot Studio. You build your robot, you have your product. Now you can have your product and the photometry. You can use that in Omniverse. So Robot Studio will be your front end. You have Omniverse, you can do the simulation of the product, you can change texture, physics of it, you can randomize, you can do photometrics, you can have different shading, different lighting, and you can do all of that to create synthetic data that you can use to train your AI model that you deploy on the real system with 99% accuracy.
Fully end-to-end physically enabled simulation. I love that.
Absolutely.
Thanks so much for all the answers to my community and much success.